In this episode, we're going to zoom in on the moment where secrets stop being an abstract storage problem and become a practical runtime problem for real applications. Storing secrets in a managed place is important, and scoping them to least privilege is important, but neither of those choices matter if the secret ends up copied into an artifact that gets shared broadly. This is where many cloud teams get surprised, because they did the careful work of securing a vault and then accidentally undid it by baking credentials into a container image or committing them into a repository during a rushed fix. Delivering secrets safely means the application receives the secret only when it needs it, from a controlled source, through a path you can monitor and revoke. When that delivery path is designed well, secrets become short-lived and accountable rather than sticky and impossible to track. Before we continue, a quick note. This audio course is a companion to our course companion books. The first book is about the exam and provides detailed information on how to pass it best. The second book is a Kindle-only ebook that contains 1,000 flashcards that can be used on your mobile device or Kindle. Check them both out at cyber.author.me in the Bare Metal Study Guide series. A good way to frame the problem is to recognize that container images, virtual machine templates, and source code repositories are designed to be copied and distributed, not protected as one-off sensitive objects. A container image might be pulled hundreds of times across many environments, and every pull is a chance for a secret inside that image to be exposed to a broader set of systems and people than intended. Source code repositories are even more persistent, because version history can preserve old values long after they were removed from the current file. Beginners often assume that if access to the repository is limited, secrets inside it are safe, but internal access is still access, and internal mistakes are still mistakes. The core idea is that secrets should not ride along with things that are meant to travel. Instead, secrets should be issued just in time to the workloads that are authorized to receive them. When secrets are embedded in images, the security failure is not always dramatic, but it is almost always irreversible in a practical sense. Even if the image is stored in a private registry, any system that can pull the image can potentially inspect layers and extract values. That might include build systems, deployment systems, developers with troubleshooting access, and support automation that mirrors images for reliability. Once a secret is inside an image, it also becomes difficult to rotate without rebuilding and redeploying every place that image is used. This creates a strong incentive to avoid rotation, which leads to long-lived secrets, which then become high-value targets. Beginners sometimes think the image is like a sealed box, but it is more like a shipping container that can be opened by anyone with access to the port. Safe delivery avoids creating that situation in the first place. Source code embedding creates a different, and often worse, kind of persistence because of how code history works. Even if a developer removes the secret from the current version, it may still exist in prior commits, branches, tags, or forks. That history might be copied into backups, mirrored into other systems, or retained for compliance and auditing. The secret's footprint becomes scattered, and you can no longer confidently say where it is or who might have seen it. Many beginners assume they can just rotate the secret and move on, but if the secret had broad privileges and lived in history for a while, the risk window may already be significant. This is why the safest strategy is to prevent the secret from being committed at all, rather than trying to clean up after the fact. Safe delivery begins by removing secrets from artifacts that are designed to preserve and replicate information. To replace unsafe embedding, you need a delivery model that treats secrets as runtime inputs rather than build time constants. In a safe model, the workload starts with an identity, requests the secret from a controlled secret service, and receives the secret through an authenticated and authorized call. The secret is then used for its purpose and ideally refreshed or reissued when needed, without requiring a rebuild of the application package. This approach also supports rotation because the secret can be updated in the managed store, and the workload can retrieve the new value when its old one expires or is replaced. Beginners sometimes worry that fetching secrets at runtime sounds complicated, but conceptually it is just replacing a static copy with a controlled lookup. The security benefit is that secrets remain centralized, governed, and changeable, rather than being scattered across artifacts that are hard to control. A key detail that makes safe delivery work is solving the bootstrap problem, which is the question of how a workload proves it is allowed to retrieve a secret without already having a secret embedded. The safest answer is workload identity, where the cloud platform provides a trusted identity to the workload itself. That identity can be authorized through Identity and Access Management (IAM) policies to retrieve only specific secrets. This breaks the dangerous loop where you need a key to get a key, which is how many teams end up embedding a permanent access key just to get started. With workload identity, the workload presents a platform-issued proof of who it is, rather than carrying a hard-coded credential. The result is that the initial trust comes from the platform's identity system, not from a static secret that can be copied. Safe delivery depends on this shift from static credentials to identity-based retrieval. Once you have a safe retrieval method, the next question is how the secret is handled inside the workload, because retrieval is only half the story. A secret that is fetched securely can still leak if it is written to disk casually, logged in error messages, or displayed in debugging output. Beginners often overlook this because they assume the secret is protected by the vault, but the vault only protects the secret until it is delivered. After delivery, the workload must treat the secret as sensitive data and avoid turning it into a durable artifact. In practice, this means limiting how long the secret lives in memory, avoiding unnecessary caching, and being careful about telemetry and diagnostics. Safe delivery, therefore, includes safe handling, because the delivery pipeline extends all the way to the point where the secret is used and then discarded. If handling is sloppy, the delivery method becomes irrelevant. Environment variables are often introduced as a way to avoid hard coding, and they can be a step in the right direction, but they are not automatically safe. Environment variables can show up in process inspection, debugging tools, crash reports, or configuration dumps, depending on how systems are administered and observed. They can also be copied into deployment manifests or templates that live in repositories, which recreates the original problem in a different shape. A more disciplined approach is to treat environment variables, if used at all, as ephemeral carriers populated at runtime by a trusted mechanism rather than by a human copying values into files. The beginner lesson is that removing secrets from code is necessary but not sufficient, because secrets can leak through many indirect channels. Safe delivery is about controlling those channels so that secrets appear only where needed and only for as long as needed. Build and deployment pipelines are another place where secret delivery frequently goes wrong, because pipelines often need privileged access and touch many environments. When a pipeline stores long-lived secrets, it becomes a single compromise point that can open many doors, sometimes across production and non-production at once. A safer pattern is for pipelines to obtain temporary credentials only for the duration of a job and only for the specific actions the job must perform. This is where continuous integration and continuous delivery, CI/CD, security overlaps with secrets delivery, because the pipeline itself is a workload with an identity that should be scoped and monitored. Beginners sometimes think pipeline secrets are harmless because they are hidden in a settings screen, but hidden is not the same as controlled, and pipelines are often accessible to many users and automation processes. Safe delivery requires treating pipelines as high-value targets and minimizing what they can access. A reliable secrets delivery design also depends on clear separation between environments, because the easiest way to accidentally cause a major incident is to allow low-trust environments to retrieve high-trust secrets. Development environments tend to be more flexible, more frequently changed, and more likely to include experimental tooling, which makes them a commonplace for leaks. If a development workload can retrieve production secrets, then a small mistake in development becomes a production breach. Safe delivery enforces environment boundaries at the identity layer, meaning development identities can retrieve only development secrets, and production identities can retrieve only production secrets. This is not just a nice organizational practice, because it directly limits blast radius when something goes wrong. Environment separation turns the delivery system into a set of controlled compartments instead of one big pool of credentials. Encryption still matters during delivery, but beginners benefit from understanding its role in plain terms. Encryption in transit protects secrets while they move across networks, reducing the risk that someone can intercept the secret as it travels. Encryption at rest protects secrets while stored, reducing the risk that stolen storage data reveals raw values. However, encryption is not the same as authorization, because an attacker who can impersonate an authorized workload might still retrieve the decrypted secret legitimately. This is why encryption must be paired with strong identity controls and careful policy design. When you combine encryption with least privilege access policies, you get both confidentiality and controlled retrieval, which is a stronger outcome than either alone. Safe delivery is therefore not about one mechanism, but about layers that reinforce each other. Logging and monitoring are what makes safe secrets delivery operationally trustworthy, because without visibility, you cannot distinguish normal use from misuse. Secret retrieval should generate audit events that show which identity accessed which secret and when, and those events should be reviewed for unusual patterns. A workload that suddenly begins retrieving many secrets it never used before is behaving like something changed, and that change might be a compromise. Similarly, repeated retrieval failures can indicate misconfiguration, but they can also indicate a probing attacker trying to discover what is available. Beginners often think monitoring is extra, but with secrets it is part of the control system, because it gives you evidence that policies are working and alerts you when behavior deviates. When logging is strong, you can also respond faster by revoking access for a specific identity without shutting down an entire system. Visibility enables precise response. Rotation and delivery must also be designed to work together, because rotating secrets is only safe if workloads can receive the new value without failing. If an application reads a secret once at startup and never refreshes it, rotation becomes a coordinated restart event that can create downtime. A safer pattern is for workloads to retrieve secrets in a way that supports refresh, either by periodically reloading, using short-lived tokens, or having a controlled mechanism to refetch when needed. The high-level goal is that secret changes should be normal, not exceptional, because normal change is easier to automate and test. Beginners sometimes think this requires complex engineering, but the conceptual shift is simple. The workload should not assume the secret is permanent. When workloads are built with that assumption in mind, rotation becomes routine and safe delivery becomes sustainable. Another area where safe delivery can fail is through accidental duplication, where a secret is retrieved correctly but then copied into places that expand exposure. For example, a troubleshooting workflow might capture runtime configuration and store it in a ticket, or a diagnostic bundle might include environment snapshots that contain secrets. This is not usually malicious. It is simply a byproduct of people trying to fix problems quickly. Safe delivery, therefore, includes designing support and operations practices that avoid collecting raw secret values and using redaction where sensitive data might appear. Beginners sometimes assume this is purely a human training problem, but it is also a design problem, because systems can be built to avoid exposing secrets in the first place. When secrets are hard to accidentally print and easy to rotate, operational mistakes become less damaging. Safe delivery reduces both technical and human leak paths. As the pieces come together, it becomes clear that safe delivery is really about keeping secrets out of long-lived, widely distributed artifacts and instead making them available through controlled, identity-based retrieval at runtime. Container images and source code are excellent at copying information, which is why they are terrible places to store access keys. Workload identity and IAM policies allow the platform to decide which workloads can retrieve which secrets, and logging makes that retrieval visible and auditable. Careful handling inside the workload prevents secure retrieval from turning into insecure leakage through logs, files, or diagnostics. Environment separation ensures that a mistake in one area does not automatically unlock another, and rotation-friendly design keeps credentials fresh without outages. Each of these concepts reinforces the next, creating a delivery pipeline that is resilient rather than brittle. By the end of this episode, the goal is for you to see secrets delivery as a security boundary, not a simple wiring task between a vault and an application. Delivering secrets safely means avoiding embedding secrets in images or source code because those artifacts are designed to travel, persist, and be duplicated. A safer approach uses runtime retrieval based on workload identity, with tightly scoped IAM permissions that allow only the necessary secrets to be fetched by the right workloads. Encryption protects secrets in storage and transit, while logging and monitoring make access observable so misuse can be detected and investigated quickly. When workloads handle secrets carefully and are built to tolerate rotation and refresh, secret lifetime can be shortened without causing outages. If you keep secrets dynamic, controlled, and accountable, then a leak becomes smaller, rotation becomes routine, and cloud access stays intentional rather than accidentally wide open.
Thanks for listening. For more audio courses, daily newsletters, and more, please visit BareMetalCyber.com.